Today we're going to be learning about mean value theorem, or MVT, in section 3.2 of your textbook. To be able to do MVT, must go through two stipulations. The first one is that the function f of x must be continuous on the closed interval a to b. So on that interval there can't be any jumps or discontinuities or anything. And then the second one is that the function must be differentiable in the open interval from those 2 points. And if both of those are true, then by MVT there will be a c on the interval a to b such that f prime of c equals fb minus fa over b minus a. Now, one problem, if they gave you a function fx equals 5 minus 4 over x on the interval 1 to 4. First, you have to state that it's continuous on a closed interval and it's differentiable on open interval. Therefore, by MVT, there exists a c on a to b such that f prime of c equals fb minus fa over b minus a. Now, I'm going to look for this side of the equation first, the fb minus fa over b minus a. And we know that f of a is just f of 1 because that's our first endpoint. So when you plug that into 5 minus 4 over 1, you get 1. And f of b is just f of 4. So when you plug that in, 5 minus 4 over 4 equals 4. So if you plug that into this side of the equation, 4 minus 1 over 4 minus 1. Now to find f prime of c, you need to get the derivative of the function. So the derivative of 5 minus 4 over x is going to give you 4 over x squared. So you plug that in over here. So you're going to get 4 minus 1 over 4 minus 1 equals 4 over x squared. Now, you know this is going to give you 1, and then 1 equals 4 over x squared, cross multiply, or multiply by both sides. So you're going to get x squared equals 4, take the square root, and x equals plus or minus 2. So you're given x equals 2 and x is equal to negative 2. But the interval is only from 1 to 4, so x equals 2 is the only number that works out. Now, what if this is the problem? There's one police car right here and a second one 5 miles away, and there's a person driving, and they pass both of them in 4 minutes. And at the first police car, the driver is clocked at 55 miles per hour, and the second one is clocked at 50. Well, we can solve to see if the driver exceeds the speed limit of 55 in that 4 minutes. So we know that time equals b4 over 60, because it's 4 minutes out of 60, which equals 1:15. So now we're going to, an ST is going to be the distance at that time. And then we know t 0. So this is going to give us, we know s 1:15 equals 5. Okay, so when we plug this in, we get s of 1:15 minus s of 0 all over 1:15 minus 0. And since we know the distance at that time is 5, we can plug that in. So 5 over 1:15, and that will end up giving you 75 miles per hour. And that's how you tell it for real life applications. Now, there's one more. you can also solve trig functions. So this is asking to solve for the function sine of x on the interval 0 to pi. And we know that sine of x is continuous on closed interval, differentiable on open interval. So f prime of x equals d. And we know that the derivative of sine is cosine. So f prime of x equals cosine x. So now we're going to set that equal to 0 because we're trying to see where cosine x 0. So for something like that, you know cosine x, you wouldn't even have to plug it into the equation. You just know that cosine x will equal 0 at pi over 2. So pi over 2. And that's it.